So how do you quote uncertainties? Well, the best way would be to show the full probability distribution function, especially if this is not a normal distribution, has fat tails or log normal or something like that. But this method is very rarely used. It should be used a lot more than it really is, because it can get a lot of trouble because you don't use it. But it's not much used, probably because it's a fair bit of work. The next best way is quoting confidence intervals. Example, the predicted rainfall tomorrow is between 2 and 8 millimeters with 95% confidence. Now this method is increasingly used by people with a good statistics understanding, probably should be used more as well, but once again it's too much work for many people. So normally people are quoting a standard uncertainty. And the GUM standard tells you there are 4 ways to quote it. So let's say we have some parameter ms. The first way you can quote it is, say, it's equal to whatever the value is, let's say 100.02147 with... So that's a bit of writing, you've had to write out the full thing, but it's perfectly clear using a standard uncertainty what the standard uncertainty is, what the value is. A quicker alternative is the bracket notation, so you can write down ms equals, then in brackets, 35. And the number in the bracket is the uncertainty in the corresponding number of the last digits over here, so it means that 47 at the end is uncertain by 35. In case that's a bit too confusing, the third acceptable notation according to the GUM standard is to write out the uncertainty in full, so you can say 100.02147 in brackets 0.00035. It's a bit more writing, but I think it's probably a bit clearer. Now the final method is actually the one that's most widely used, but the GUM actually deprecates it. That's to use the plus or minus notation. So you can say ms equals 100.02147 plus or minus 0.00035 grams. That's the one you'll see most often. Why doesn't GUM like it? Well, they think that plus or minus to most people implies that it's a range. So if the average person sees plus or minus this, they assume it'll be in the range between minus that and plus that 100% of the time. Whereas as we've seen, what it actually means just is that 68% of the time it'll be within this range. So that's for that reason the GUM people prefer to use one of these. Now the most common way to quote uncertainties is purely by giving the number of significant figures. It's not a very good method, but it gives a rough idea. Let's say, for example, you knew that a particular force was equal to 3.024 with an uncertainty in the last digit of 2 newtons. Now that means the last digit is uncertain. It might be 6 or 2 or something like that, and that's how you should normally quote it. If you just write it as 3.024, that's implying that the last digit may be a little bit uncertain, but the other digits in front of that are probably pretty certain. So that's what you should do. The general rule is quote something so that the last digit has a bit of uncertainty in it and the other ones are not uncertain. So likewise, if you see, for example, someone quotes a mass equals 6.3552, that's telling you that the uncertainty must affect the last digits. The uncertainty could be 0.0001 or 0.0005 or something like that, but it couldn't be like 0.1. If it was 0.1, you should have quoted it as just 6.3 or 6.4. We're not too fussed about the exact number of digits you quote. If you go plus or minus 1 digit, no big deal. What's really objected to in this course, and in general in physics, is quoting far too many decimal places, just because your calculator told you the answer was 6.431792881, but in fact it's only accurate to 10%, then all these digits are meaningless. And they could fool someone into thinking you actually know this to like 10 decimal places, when you don't even know it to 1 decimal place. So general rule is only quote numbers to about the accuracy in which you know it. Don't quote digits much beyond that which are meaningless.